I would like to show you a creative method for driving a Mosfet. It's very simple and only works at low switching speeds. But alright, so basically I'm working on a 3D printer and I need to be able to control a Mosfet to turn a heater on and off. And a heater pulls 5 or 10 amps, and that's quite a bit. And the 3D printer computer is a 3.3 volt microcontroller, and it needs to be able to turn the heater on and off in order to regulate the temperature to melt the plastic. Alright, so the first issue is that most MOSFETs require at least 5 volts to really get the current flowing. So a MOSFET is it's a type of transistor, and yeah, I think that there's something like, anyway, basically there's 3 pins. The current flows from the pin 1 to pin 2. Well, it's not really pin 1 and pin 2, I don't know, I just this is called the drain and the source, and I think that oftentimes these words are very confusing in describing what's going on, but this one here is called the gate. Anyway, a MOSFET is a voltage controlled switch, essentially, or that's how we're using it at least. Whenever the voltage on the gate, that's the voltage with respect to ground, whenever that voltage increases to about 5 volts, then the MOSFET will start conducting. Otherwise, if the voltage is less, then it won't turn on at all. And then if you bring it up to 10 volts, it'll allow even more current, and then at some point it's like fully open or fully conducting, and it'll just act as a short, pretty much. So the problem is 3.3 volts from the computer's I/O pin is not quite enough to get the MOSFET to turn on. It might be enough to allow just a trickle, a couple milliamps to flow, but not enough to turn the heater on. And that's a problem, because that means that the MOSFET will be acting as a resistor, a big resistor, and it might heat up some, but ultimately the heater won't even turn on. Okay, so I started attempting to solve this with a few different basic driver circuits. The driver circuit goes between the microcontroller and the MOSFET. So there's the driver circuit, and then there's the MOSFET. I don't know. And in my case, I pretty much just needed to level shift to get the voltage from 3.3 to 5. Well, the first thing that I tried was using a pull-up resistor and a NPN BJT transistor, and the way this works is when the transistor is off, then this pin, which goes to the gate of the MOSFET, is driven high to 12 volts, and that'll really turn that MOSFET on, and it'll be fully on. And then whenever the transistor is activated by the computer, it shorts this pin to ground, and now the gate is driven to 0 volts. So the gate will either be 12 volts or 0 volts instead of 3.3 volts or 0 volts, which is good. The problem with this is that when the I/O pin is on, the gate is off, and that inverts the logic, and unless you're going to do a software update to change that in the microcontroller program, which you definitely can do, but I wanted something that was not inverting. So it's going to try another one. This one uses 2 transistors, and it is called a push-pull because of the way that the transistors are interacting with each other. And this one uses a PNP transistor and an NPN transistor. So the NPN transistor has the arrow on the emitter pointing away from the base, and on the PNP transistor it's pointing towards it. That just shows the direction that current has to flow from base to emitter in order to turn on the transistor anyway. Alright, and the way this one works is only one of the transistors will be on at a time. If they were both on, then 12 volts would be shorted to the ground, and that would just smoke. So, but if only one of them's on, then the output will either be 12 volts or 0 volts. And this is a pretty popular design, except what I failed to recognize was that the voltage here driving the gate of the Mosfet will only ever be as high as, it will actually be 0.6 volts less than the voltage driving these transistors. So if this is 3.3, and I tested this, I only get about 2.5, 2.6 volts at the gate, and that really doesn't solve my problem either. In that case, if I had a higher voltage at the input to the driver, then you could use something like this to drive a really big Mosfet with a higher voltage but a very low current device. But I actually don't think that would work great with low voltage logic. So finally, what I ended up doing uses no transistors. We go from 12 volts through a resistor to the gate, and then we basically make a voltage divider, and instead of going to ground, we go to our I/O. Okay, so when the I/O is 0, at 0 volts, the circuit acts exactly like a voltage divider, and I think I made the top one a little higher. This is 47K and this is 10K. Okay, when the I/O is 0, then we'll see about 2.2 volts, which is not enough to turn on the Mosfet, so it's off. But when the I/O is 3.3, now we see 1.5 from 1.5 volts above the 3.3, which ends up actually being about 4.9 volts. And this only will work safely if you use high value resistors, so that current, well, you're going to see current flowing backwards through your I/O, and if that current is too high, it'll damage your chip. So this really only works with low frequency switching because, well, the thing about MOSFETs is they don't change their speed instantly. They actually act like a capacitor that has to build up charge in order to turn on. And if your current's flowing very slowly through a high value resistor, it'll take a long time to turn a MOSFET on and off. But we can't drop these values too low, otherwise we could damage the I/O. Now, I was concerned that this might not work with the PWM signal that I'm driving it from the microcontroller, but it's only a couple hundred hertz, which is really, in the big scheme of things, pretty slow, and it is working pretty well. So, alright, so this is the 3D printer control board right there, and here's the circuit that I've added temporarily. I'm going to command it to heat up. Right now it's reading about 50 degrees Celsius, and I'm going to set it to just 75 because that should show at least enough. Alright, it said 40 degrees, now it's 50, and as it approaches 75, you saw, I don't know if you saw the light kind of flicker, and I probably got to tweak the heater controller settings some, but the fact that the LED's turning on and off means it's working. No, so in conclusion, if you find yourself in a scenario where you need to drive a MOSFET at not all that high speeds, and you have to do so with a low control voltage, like 3.3 or less, you might be able to get away with just using a couple resistors to do that. So thanks for watching.